What if I tell you that I have a simple solution to the problem of solving all of your problems in pH and all of the calculations? Here's how to do it. If you're a new viewer, welcome to the Distinguished Scholars Academy. This is our channel. We post educative content. Please like this video, share it with your friends, and subscribe or follow us. Thank you. So now let's come back to solving your problem with calculations in pH. The first thing is to know the full meaning of pH. pH means potential or power of hydrogen. And of course, you know it runs on a scale that goes from 0 to 14. Okay, just like your number line in secondary school, we are from 0, the center point is 7, and the end there is 14. We know that 7 represents neutral, 14 above represent alkaline, and behind represent acidic. All right, now beyond that, we need to now know how to calculate pH. How do we calculate pH? Of course, mathematically, the formula for pH has been derived to be a negative logarithm of hydrogen ion concentration. Leave all of that English. It says pH is equal to minus log of H plus, negative log of hydrogen ion concentration, or sometimes you may come across it written as H3O plus. Now, what do you do when you have a question on pH? Here are some common questions that you most likely find in your examination. At least one will come out in your 2026 JAMB exam, and you should not miss the question. Okay, if examples I have here, calculate the pH of the following. Number 1, 0.01 molar concentration of aqueous HNO3. All right, let's start with that. Pay proper attention. Pick your pen and a piece of paper and join me as we do this. Okay, to get the pH of 0.01 molar HNO3, of course, aqueous, because it's going to dissociate. If it doesn't dissociate, you cannot get hydrogen ion that you want to use the concentration in the calculation of your pH. So the first thing you do now is that you need to dissociate this acid into an aqueous solution. So you're going to have HNO3, of course, reversibly giving us H plus and NO3 minus. All right. So now that we can have our H plus, which we are going to use in our formula pH minus log H plus, it means that the concentration you are given in the question is not the concentration that you are expected to use here. That is the mistake that many JAMBites make in solving questions on pH, and you should avoid that mistake. All right, so how do we get the concentration of H plus? The concentration of HNO3 has been given to be 0.01. So we say that from this equation, 1 mole of HNO3 is giving us 1 mole of H plus, right? So 0.01 molar concentration given in the question will give us X. And by the time you cross multiply, of course, X is going to be what? 1 molar concentration. All right, next, if you're going to do that, you know that's going to be X times 1 equal to 0.01 times 1. Then you divide all through by 1, you're going to still get the same value. All right, don't always think that you're going to always get the same answer, because in cases where you have dibasic or tribasic acids like H2SO4 and H3PO4, you may have to get a wrong answer. Now let's go. We've gotten the concentration of our H plus to be 0.01 molar H plus. All right, so we write that out. Concentration of H plus is 0.01 molarity. Now we come back to this formula. We now say that the pH is equal to minus log. Now you put your value 0.01. Okay, now like you must have learned before, we drop tricks about how to calculate stuff in order to save your time during examinations. So how do you do this without calculator in an exam? You don't need to waste your time. Of course, 0.01 is the same thing as what? 10 raised power minus 2. So if I come here and I say minus log 10 raised power minus 2, if you are not very conversant with mathematics, let me quickly help you out. In mathematics, when we have log a raised power b, it will be the same thing as this comes to the back, so it becomes b log a. All right. So if I have log 10 raised power minus 2, it becomes minus 2 log 10. All right. So what would be your own answer by the time I do log 3 raised power 2? What would be your answer? Type that in the comment section. All right. Quickly do that while we proceed with our question. So now, when you come back to this, pH is going to be minus log 10 raised power minus 2. So it becomes what? Exactly. It becomes, don't forget this minus is there before. Then you have minus 2 okay, log 10. Now let me quickly give you this short trick also. It's all about being smart. Okay, so for logarithm, there are a few numbers that you can cram. Log 1 is equal to 0, log 2 is equal to 0.3, log 3 is equal to 0.5. Now the rest of them follows sequence. 4 will be 0.6, 5 will be 0.7, 6 will be 0.8, 7 will be 0.9. Of course, there's 8, there's 9, there is 10. Now you may be wondering, how we now get 8? I don't usually give log 8 or log 9. The last one I'll give is log 10, which is equal to 1. If I want to get log 8, I'll say 8 is 2 times 2 times 2. Is that not? Index form, it becomes 2 raised to power 3. Now going back to our initial law, if you have log 2 raised to power 3, it becomes 3 log 2. And what is log 2? 0.3. So that's 3 times 0.3. Is that clear? All right. So you can practice more to get that. There will be another video that teaches you how to do logarithm without wasting time using calculator. All right. So here we have our pH equal to minus times minus. That is plus. Of course, you know that in your mathematics. So this becomes 2. And what is log 10? Log 10 is what? 1. So 2 times 1 is equal to 2. And that is the answer to that question. The pH of 0.01 molar HNO3 is 2. All right, so now let's do the second one. The third one is going to be your own practice. So we quickly solve that of H2SO4. So don't forget, the first thing is to dissociate your acid. So you have H2SO4 breaking down into H plus and SO4 2 minus. In case you do not know how to break down solutions like this, I did a video on solubility products, and in that video I explained how to get the ions that you get when you dissociate solutions. So go to our YouTube channel and you find that there. The link will be added to this video. All right, so the next thing to do now is we'll check if this equation is balanced. This is H plus, this is 1 mole of hydrogen, this is 2 hydrogen here. So what do? We add 2 to this side. Okay, 1 so 4, 1 so 4, 4, 4. Everything is balanced now. So we say now from our concentration, one of these is giving us what? 2, right? So 0.05 given will give us x. So when you cross multiply, you have x equal to 0.05 times 2 all over 1. And that gives us 0.10 molar concentration. Now, this is the concentration of our H plus. So we'll go back to our formula now. Right, H plus is equal to 0.10 molar concentration. If I were you, I already know the answer to my question because this is 10 raised to the minus 1, and therefore the pH is going to be 1. But let's do that quickly. So we say pH equal to minus log 0.10. We say this is 10 raised to the minus 1. So rather than writing this, I'll just put 10 raised to the minus 1. And this comes to the back, it becomes minus 1 times log 10, and that is what? 1 times 1, which is still 1. So the pH of this solution is going to be 1. So this is your own exercise to do. Calculate the pH of 0.01 molar NaOH. Now beyond that, what else do you need to do? We need to calculate, what if you are not told to calculate the pH, but you are given the pH and you have to calculate the concentration? What will you do? All right, very, very easy. There's a derivation for that, but because nobody is going to ask you whatever way you are deriving in an exam hall, what matters is what you know and how you get your answer. So I'll simply give you the solution to it. To get your concentration, hydrogen ion concentration will be equal to 10 raised to the power minus pH. So if you just pick your calculator and they give you pH, just do 10 raised to the power negative pH, you get your hydrogen ion concentration. So for example, this question, they give us HNO3 with pH equal to 4, and we have to look for the concentration of the HNO3. All right, so this is H plus. We said that H plus normally is going to be 10 raised to the power minus. We've been given the pH to be 4. Okay, so that will be 10 raised to the power minus 4. And of course, that's the hydrogen ion concentration, which you can rewrite to be 0.0001 molarity. That's your hydrogen ion concentration. You will now go back to it that, okay, normally HNO3 is what we are looking for, and that gives us H plus and NO3 minus. Since it is 1 against 1, that means the concentration of H plus is the same thing as that of HNO3. But if it was 2, that means you have to multiply or divide as it applies. All right, that's for concentration. So you can check out more examples and use that in your own spare time. Now the last part is, if you are now told to calculate pOH of an acid, or you are told to calculate the pH of an alkali, normally acids cannot give you pH, or let's say acid cannot give you H plus. Do you get? Because pH requires that you use H plus. So, and they are giving you an alkali, and you are expected to calculate the pH. So what you simply do is that, in this case, this is pOH of an acid. I have HNO3. When I break down HNO3, it's going to give me H plus and NO3 minus, right? These are all aqueous. So we leave that. So the pH will be equal to minus log H plus. If it's pOH, it's going to be minus log OH minus. But we don't have OH, and they ask us for pOH. So what do? We first calculate pH. Okay? So if you have to calculate the pH now, what they gave us is 0.01 molar HNO3. So what do? As usual, this is the same thing as 10 raised to the minus 2. And you can already guess, right? The answer is going to be what? 2. You say pH equal to minus log 10 raised to the minus 2. And that becomes minus 2 log 10. Okay? And that becomes minus 2 times 1, which is, that becomes minus times minus, that's 2. 2 times 1, 2. So now you've gotten your pH. There's a relationship that you can derive using your pH and pOH with the P of water, or using your ionization constants Ka, Kb, and Kw. All right. So all of that, what we are trying to bring out here is that the relationship says pH plus pOH is equal to 14. So now we got our pH earlier to be what? To be 2. So this is 2 plus, we are looking for pOH equal to 14. So pOH as the subject of the formula is 14 minus 2. This 2 comes here, it becomes minus, and pOH becomes 12. And simply you've calculated the pOH of an acid, not by using OH minus, but by simply using the simple equation pH plus pOH equal to 14. Now, what is the last one I'm going to do? I'm going to do 2. You're also going to do 3, making 3 exercises that I have for you in this video. All right. So this one says, which of these is most acidic? Okay, which of these is most acidic? Now we are going to just get their acidic nature, and we'll be able to use it to compare to if it is acid. Don't forget that on your pH scale, 7 is neutral, greater than 7 is alkaline, less than 7 is acidic. So if you have pH equal to 3, that is what? Acidic, of course. Now if you have pH equal to 4, you also know what that would be. Acidic. Okay, if you have pH equal to 7, what does that tell us? Neutral. Okay, if you have pH equal to 12, what does that tell us? It tells us that it is alkaline. But if we want to compare it now, if we have all these solutions, maybe some of them are acid or alkaline. Now we now say that, okay, let's add an option E. And option E says pOH equal to 12. The same pOH and pH. Now if you have pH equal to 12, because what we know is the pH scale, so you don't know if this thing is actually maybe acidic or alkaline. You may want to guess that it is alkaline, but let's confirm. If pH equal to 12, we say pH plus pOH equal to 14, right? So it means that pH of this pOH will be 14 minus 12, which is what? 2. Now that even tells us that the pH of this thing is 2, and it is even like the most acidic of everything that we have here. Do you get now? So it means that the fact that they give you pOH of 12 does not mean that it is alkaline. If you are trying to check for acidity or alkaline nature, you have to use your pH. All right. So that will be all that we have here. Please take your exercise in the video. All right, you're going to take your exercise in this comment section. The question that you have here, question 3, calculate the pH of 0.01 molar NaOH, and drop your answer in the comment section. Now before you go, let me bring back again the simple trick that I've tried to explain earlier. pH is just negative log H plus, and especially it is more easy when they bring it out in exam as all those 0.001, 0.01, or it has to do with 0.1, 0.1, 0.1. What you simply do is, these things are the same thing as 10 raised to the power minus 3, 10 raised to the power minus 2. So eventually this minus will cancel out, and log 10 is 1. So you don't need to be doing all the mathematics. When I give you 0.01, and it is a monobasic acid like HNO3, HCl, you just simply count the zeros. How many zeros do we have here? 1, 2, 3. Your pH is going to be equal to 3. If you have 0.01 HCl, it's a monobasic acid. So you just count how many zeros do we have? 2. Your pH is going to be equal to 2. So tell me, additionally to your question 3, what will be the pH of 0.0001 molar HCl? That's your second exercise. So exercise 1, exercise 2, drop that in the comment section. I'll see you in my next video. Thank you very much.